Hi, my name is John Bush, and this is Physics 2212, Lab 2, the magnetic field of a bar magnet. So the purpose of this lab was to use the Biot-Savart law in order to measure the magnetic field both on and off axis of a bar magnet. And then once we were able to do that in real time, we used that to simulate the model using a glow script to help visualize the relationship between the distance and strength of said magnetic fields. In terms of the results, I found that there exists an inverse relationship between the magnetic field and distance, meaning that that as the magnetometer moved closer to the magnet, the x component of the magnetic field increased. The magnitude of the magnetic field for the 45 degrees off axis that I found was around 9.5 times 10 to the negative 5 Tesla. And then the resultant n value I got was negative 2.0042, and mu was 7.823 amps times meters squared. Some of the fundamental principles that we used during this lab were the Biot-Savart law, which demonstrates the relationship between the magnetic field at a point and a current, as well as the magnetic dipole moment, the bar magnet that's treated as a loop of current, and then the dipole field, which is essentially just kind of a simplification of the Biot-Savart law. Some assumptions that we made going into this lab would include that there were no other electric fields that were acting on the magnetometer other than the Earth and the magnet, and that the sensor axis was aligned with the dipole axis there. Some potential sources of error that could have occurred while doing this experiment, or variations in the tape position, or realignment between each of the trials that we did, just kind of like a human error. And then potentially possible external sources of different metals or anything producing certain electric fields that could possibly interfere with the experiment. So during this experiment, we used a magnetometer app on the iPhone and oriented the phone such that the bar magnet's field was perpendicular to the Earth's field. Some of the components of this experiment included the system, which was just the iPhone in this case, and then the surroundings in this instance in this lab, which is the bar magnet. I also aligned the sensor axis north and the position magnet east to west. And then we were able to, we were able to record the maximum x component at different positions to map the field strength in relation to the distance. So after logging the data I recorded from the experiment into the Excel sheet provided, I was able to plot ln of bx versus ln of r. The resultant linear fit produced a result of negative 2.0042, which was pretty close to the theoretical value of negative 3 for a dipole. Then after that, I was able to extract the constant k from the y-intercepts, as well as using the magnet's dipole moment mu, which was aligned with the expected values that I found. Here's some calculations that we did. So I set ln, the vector bx, equal to ln of k plus n times ln of r. And then I got the results in n, negative 2.0042. And then raising both sides to e, we were able to find k as well, which I found was 1.543 times 10 to the negative 6 in this instance. And then setting the absolute value of the magnetic dipole of the bar, I was able to find mu being 7.823 amps times meters squared, and then r was just 1 meter. So after doing the experiment, I was able to use the glow script model and input all the data. So using the glow script model provided, I was able to write a function for dipole B, which computes the full dipole field vector from the measured mu value. Then using that value, I plotted the magnetic field lines at 2 points on the axis, 4 perpendicular points, and then along a 45-degree line as well. The resultant 3D visualization model matched the strength of the field and the trend that I saw while doing the lab experiment. Then a couple of what ifs. So how would the results of the experiment change if we did not orient our magnetometer to align with true north? And I said if the meter was at an arbitrary angle instead of aligning to true north, then Earth's field would interfere with the magnet's field and possibly throw off our measurements. The next question being, what if you redid the experiment, but instead of using a signal magnet, you use the two identical magnets stuck together end to end? How would you expect your measurements to differ? And I said if we were to tape the two identical magnets together end to end, the magnitude of the field we measure would be approximately twice as large. However, it would still point in the same direction. So yeah, thank you so much.